This next exercise we're going to work on is expanding brackets. Now when you see the word expand, what you're actually thinking in your mind is, oh that's right, I need to get rid of my brackets. What you will often notice though is in a question it will say expand and simplify. So what that means is get rid of the brackets, and then the simplify part is group all of your like terms. So for all of these questions, we're going to work through some questions from exercise 3.5 and 3.6 from page 172 of the textbook, and we're just going to expand and simplify. Now, when we're expanding this, the way we're going to do it is also known as the distributive law. Now, you don't need to get too worked up with what that actually means, but what it basically means is everything here needs to be multiplied by everything in there. So this is how we do it. To expand brackets, what's directly in front of the brackets, we know there's actually a multiply sign there, but that 2 needs to apply to everything inside the bracket. So it needs to apply to both the x and the 5. So what we're left with is 2 multiplied by x is 2x, and then the plus, so we bring that across, and 2 multiplied by 5 is 10. And that's expanding brackets. It's that simple. That's also called the distributive law. So everything on the outside gets multiplied by everything on the inside. So I'm just going to go through now and I'll do all of these and you can just watch along. So 8 times x is 8x. And then 8 times negative 2 is going to be negative 16. Alright? And that's as easy as it goes. So with all of these, I encourage you to write these distributive lines at the top, those red lines. Negative 7 times x is going to be negative 7x, and negative 7 times positive 1 is going to be negative 7. Negative 9 times c is negative 9c. Negative 9 times negative 6 is positive 54. Next one, m. Write in our lines at the top. Oops, sorry about that. I'm not sure what's happened there. So then what we have is x times that, and x times that. So it's going to be x squared, and then the x times 3 is plus 3x. For this next one we have negative x times x. It's going to be negative x squared plus, because a negative and a negative makes it positive, 8x. For this next one, keep in mind that because there's no positives or negatives, this term that's in front of the brackets, we need to multiply by everything inside the brackets. So 3x times x is going to be 3x squared plus 3x times 2 is 6x. And again, everything that's in front of the brackets here, including this minus sign, needs to be multiplied by what's inside those brackets. So negative 2x times x is negative 2x squared. Negative 2x times 7, 2 7s are 14, so it's going to be minus 14x. Alright, on to question 2. So this is exactly the same, except we've got now 2 parts to it. So we need to apply the distributive law, like this, to both sides of our fraction, both sides of our problem here. So 3 times x is going to be 3x. 3 times negative 2 is going to be minus 6. That plus sign we just bring across. 2 times x is going to be 2x, and 2 times 4 is going to be positive 8. Now this is what I was saying before about when we're expanding we often need to simplify. So what that means is we need to group our like terms. So our like terms here are the 3x and the 2x, as well as the minus 6 and the positive 8. So if we simplify this then, it's going to be 3x plus 2x is going to be 5x. That's the blue bit. And the green bit is going to be negative 6 plus 8 is positive 2. Just like that. Alright, so for this next one, apply the distributive law. 4 times 2x is going to give me 8x. 4 times negative 3. 4 3s are 12. It's a negative, so it's going to be negative 12. Okay, now this is the tricky bit. This minus, just like before when we had this negative 2 up here, that minus applies to both things inside that bracket. So it's going to be minus 1, because we know there's actually a 1 there. We always just don't write the 1, but there is a 1 there. So it's going to be negative 1 times 6x is minus 6x, and then negative 1 times negative 1 is going to be positive 1. And again, we need to group our like terms to simplify, and that's going to be 8x minus 6x is 2x, and negative 12 plus 1 is negative 12, moving in the negative direction 1, it's going to be negative 11. Question E now, apply the distributive law to both sides. Keep in mind that that negative 2 needs to be applied to both the 3a and the negative 5. So a times 2a is going to be 2a squared. A times 3 is going to be plus 3a. Negative 2 times 3a is going to be negative 6a. And negative 2 times negative 5 is going to be plus 10. Okay, can we group our like terms? Yes, we can. 3a minus 6a. Now notice here how we have a squared. We can't actually add the 2a squared to the 3a because they're not like terms. So we just have to stick with the 2a squared. 3a minus 6a is going to be minus 3a plus 10. Again, for this next one, we apply the distributive law. That 5, the negative, make sure that you apply that to both of them as well. So negative 7y times y is going to give me 7y squared. 7y times negative 3 is going to give me negative 21y. Negative 5 times y is negative 5y. And negative 5 times 2 is going to be negative 10. Again, we can group our like terms. 21y minus 5y is going to equal 7y squared minus 26y minus 10. Alright, my apologies if any of these, if there's a simple error here, but it should be right. Okay, question 3 looks at the distributive law, only now what happens is we have 2 sets of brackets. And what we need to make sure of is that we multiply everything in this first set of brackets gets multiplied by everything in that second set of brackets. Right. Now the way we do this, the distributive law, it's also called FOIL. Some of you may have known that, which is firsts, outsides, insides, lasts. So the firsts means x times the y, and then the x times the 5 is going to be o. So the firsts there, the outsides, the x and the 5, the insides, the 6 and the y, and the lasts, the 6 times 5. Remember that those lines that we draw above and below, they're actually representing their numbers that we multiply together. Okay, so first, x times y is xy. Outside, x times 5 is plus 5x. Then the inside, 6 times y is plus 6y. And then the last, 6 times 5 is plus 30. Now, do we have any like terms here? And the answer is no, because this first term has both an x and a y. This one has an x, this one has a y, and that's got no variables in it there. So what that means is there's no like terms because there's none that have exactly the same letters and the same number of letters. Okay, let's apply the distributive law again. Firsts, outsides, insides, last. Okay, so if we multiply out first, r by t is going to be rt, then outsides, r by negative 8 is minus 8r. Remembering that these mean multiply, okay? Insides, 5t is plus 5t, and then lasts is 5 times negative 8, 8 times 40, so it's going to be negative 40. And again, we've got no like terms, so we can't simplify that any further. Okay, this next one. just like that. A times y is ay. A times negative 4 is minus 4a. Negative 3 times y is minus 3y. Negative 3 times negative 4 is positive 12. And again, we don't have any like terms, so we can't simplify that any further. Okay, nearly there. 4p firsts, outsides, insides, lasts. 4p times m is 4p or 4mp, because it doesn't really matter, it doesn't change the answer at all, but it's just convention that we write them in alphabetical order. Then we go 4p times n is plus, sorry about that, 4pn, and then we have insides, q times n is plus qm, plus q times n is qn. Okay, and now we can just rewrite those mp, mq, and nq. Sorry about that, we just needed to write them in alphabetical order. Right, do we have any like terms? The answer to that one is no. Alright, so next one, page 178. Let's look at some of these using our special products. So when you see d minus 1, the temptation is to go d squared minus 1 squared. Okay, just so you know, that's not correct. Or that is incorrect, it's wrong. Alright, we need to be very clear on that, because what it actually means is d minus 1, and this squared means this number multiplied by itself. So the way we write it is we go d minus 1, and then we need to multiply it by itself. So we go d minus 1, d minus 1. Once we've done that, then we apply our distributive law like this. First inside, outside, last. And what we get is we get d squared minus d, minus 1d, and then we go inside, which is minus 1d. Then we go minus 1 times minus 1 is positive 1. Okay, we can simplify that by grouping our like terms. So d squared minus, now if we've got minus 1d and then we take away another d, we have minus 2d plus 1 there, and that's our answer. So likewise here on question B, m plus 5 squared means m plus 5, m plus 5. Once we've got that, we use our distributive law, first, outside, inside, last, FOIL, and then we can expand it. So it's going to be m squared plus 5m plus 5m plus 25, which equals to m squared plus 10m plus 25. Right. K plus 2 squared, we rewrite it, k plus 2, k plus 2. Okay. And then we use FOIL to expand it out. Remembering it's always good just to have one equal side per line. Your equal signs should be directly underneath each other and it'll work downwards. So it's going to be k squared plus 2k plus 2k plus 4. Now if you're wondering where these two separate 2k there and 2k here came from, the first one was multiplying k by 2 up the top there, and then the other one was doing this 2k down the bottom. That's how we come up with the two versions of the 2k. Then we simplify it by grouping our like terms, k squared plus 4k plus 4. Alright, the last one we're going to do now is p minus 3. So we go p minus 3, and then we go p minus 3 because it's squared, so we multiply it by itself. We then expand it out using our distributive law like so. And we go p squared minus 3p minus 3p, negative 3 times negative 3 is positive 9, which is equal to p squared minus 6p plus 9. Alright, now one thing I might just point out is in question 6, let's just have a quick look at question 6 now. there's what's called the difference of two squares rule. And that's where we have something like this, m plus n, and then we go m minus n. So everything's the same except this plus sign now turns into a negative sign. So we can still just use the distributive law to multiply that through,